We know that Jerry loves cheese. He saw this lump of cheese and decided to go towards it from this path, which is 5 meters long. But then he saw Tom sleeping on this path and he was unable to take this path. So what he did? He took this path, which is 3 meters plus 4 meters long. Alternatively, he could have taken this path, which is 6 meters long, or this path, that is 4 meters here, and then 3 meters. So how many paths do you think are possible between these 2 points? Well, yes, there could be a number of paths between these 2 points. And given any 2 points, the length of the path traveled may be different in each case. This length of the path travel is called distance. So now if I ask you, what is the distance traveled by Jerry to get to the cheese? We know he took this path and the length of this path is 3 meters plus 4 meters, that is 7 meters long. So we can say that the distance traveled by Jerry is 7 meters long. Now we have seen that distance is equal to the length of the path taken. The length of the path taken is a numerical value and it requires only magnitude, and hence distance is a scalar quantity. Distance just tells us that how much did a body had to travel to reach to the point. That is, how much did Jerry had to travel to get to the cheese. We can measure distance in kilometers, miles, centimeters. However, the standard unit for measuring distance is meters and it is denoted by m. So now we see that Jerry has reached to the cheese. Now if I ask you, how far is Jerry from his home? What will be your answer? Well, sometimes you may say 7 meters, sometimes you may say 5 meters, sometimes you may say 6 meters, depending on the path which you are seeing. So how am I supposed to know exactly how far is Jerry from his home? In order to avoid this confusion, we take the straight line joining the initial position and the final position to describe how far is a body from the initial position. This is done irrespective of the path taken. Now this straight line is the shortest distance between any 2 points. You may ask, why do we take the shortest distance and not the longest distance? Well, because we do not have a unique longest distance. Let me explain it. If you consider this to be the longest distance, then I can draw this line and say that it is longer than this. So you may say this is the longest distance. No. I can draw yet another line which is still longer than this line. And I can continue doing this again and again. So we see that there is no unique longest distance. However, the shortest distance is unique. So to describe how far a body is from its initial position, we take the shortest distance. For example, in this case, we always say that Jerry is 5 meters away from his home. Whether he has traveled by this path or this path, he will always be 5 meters away from this home. Now, is this information sufficient that Jerry is at a straight line distance of 5 meters from his home? Let us see. Tom comes to know that Jerry is at a distance of 5 meters from his home and he decides to get hold of Jerry. But then he was confused. Yes, he was confused because Jerry could be here. This is a straight line distance of 5 meters from Jerry's home. Or Jerry could be here. even this is a straight line distance of 5 meters from Jerry's home, or here, or here. In fact, we had just drawn 4 here, but there can be a number of possibilities where Jerry could be, even after specifying that he is at a straight line distance of 5 meters from his home. So what is lacking here is direction. Yes. So if Tom would have known that Jerry is 5 meters towards northeast from his home, then he would have been able to get a complete picture of Jerry's position. And this difference between the initial position and the final position is called displacement. So displacement is equal to final position minus initial position. And as we have already seen, displacement needs direction. So displacement tells us how far is a body from its initial position, and it requires direction. So displacement, as the name itself suggests, dis stands for change and placement stands for position. So displacement is a change in position. It requires both magnitude and direction, and hence it is a vector quantity. So distance was a scalar quantity, but displacement is a vector quantity. The length of the shortest path between 2 points gives the magnitude of displacement. So whatever may be the path taken, but the magnitude of displacement will be given by the length of the shortest path between the 2 points. And the length of the shortest path between the 2 points is the length of the straight line joining those 2 points. The direction is taken from the initial position to the final position. Standard unit for measuring displacement is meters, and it is denoted by m. And how do we represent it? Well, if A and B are 2 points, then we represent displacement between A and B as AB vector. This arrow stands for the vector sign. So displacement is a vector quantity, and we always need to mention a direction. So we can say that the displacement of Jerry is 5 meters from his home towards the cheese, or we can say that displacement of Jerry is 5 meters from cheese towards his home. As you might have noticed, that mentioning in terms of home, cheese is not always very convenient. So what do? We fix a sign convention. We arbitrarily assign one direction as positive, and since we are studying one-dimensional motion here, so on assigning one direction as positive, the exact opposite direction becomes negative. So if we assign home to cheese as the positive direction, cheese to home, that is the exact opposite of this, becomes the negative direction. So if Jerry travels from his home to the cheese, we say his displacement is plus 5 meters. If Jerry travels from cheese to his home, we say that his displacement is minus 5 meters. So what is the distance and displacement? If Jerry starts from his home, follows this path and goes to the cheese, then he comes back via this path to his home. So what is the distance and displacement of Jerry for the entire journey? Well, we know distance is equal to length of the path taken. So what is the length of the path taken? First he travels 4 meters. Then he goes 3 meters. Then again 4 meters. and again 3 meters. So the total length of the path taken is 4 plus 3, 7, plus 4, 11, plus 3, 14 meters. So this is the distance traveled by Jerry. Now what is the displacement of Jerry? We have already learned that displacement is equal to final position minus initial position. What is the initial position of Jerry? This one. What is the final position of Jerry? This. So we see that the initial and final position of Jerry are the same, and displacement is equal to final minus initial, and since final is equal to initial, so displacement is 0. So we see that Jerry has traveled some distance and he has come back to the point from where he started. So he is forming a closed path. That is, when you reach the same point as you start from, it is called a closed path. And displacement along a closed path is 0. Why? Because distance tells us how much a body has traveled. That is, he has traveled 14 meters. And displacement tells us how far a body has traveled. And since he has come back to where he started from, so displacement is 0. Ajay starts from his home and walks towards his school, which is 2 kilometers east of his home. He then goes back to his home and walks towards the market, which is 1 kilometer west of his home. What is the distance traveled and displacement of Ajay since he started from his home? Now for distance traveled, we need to find the length of the path he has traveled. So first he goes 2 kilometers to his school. Then he comes back. So again 2 kilometers. And then he goes to the market, which is 1 kilometer. So it is 2 plus 2 plus 1, that is 5 kilometers. So distance traveled by Ajay is 5 kilometers. What is the displacement of Ajay? Well, for displacement, we are not bothered about the path which he has traveled. We just want to find the difference between the final position and the initial position. So the final position is the market and the initial position is his home. So displacement is equal to final minus initial. So the magnitude is 1 kilometer. And what is the direction? Well, direction is from initial to the final position. So 1 kilometer towards west. So 1 kilometers towards west of his home. Can distance ever be equal to the magnitude of displacement? Let us see. Let us consider only the first part of the previous question. That is, Ajay started from his home and went to his school, which is 2 kilometers east of his home. So what is the distance traveled by Ajay in this case? It is 2 kilometers. What is the displacement of Ajay in this case? It is 2 kilometers towards east. So we see that the magnitude of displacement in this case is equal to the distance traveled by Ajay. So what we conclude is if the direction of motion does not change, then the distance is equal to the magnitude of displacement. So let us compare distance and displacement. Distance is the length of the path traveled and displacement is the change in position of an object. Distance is a scalar quantity and displacement is a vector quantity. So distance does not require direction. However, displacement requires direction. So it is a vector quantity. Distance depends on the path taken. Yes, because it is the length of the path taken. So obviously it depends on the path taken. However, displacement depends only on the initial and the final position. It is irrespective of the path taken by the object. Distance can never be negative. However, displacement can be negative if the displacement is in the negative direction which we had assigned. Distance cannot be 0 if the body moves. So if the body moves, there will be some path which it has taken, and the length of that path cannot be 0. So distance cannot be 0 if the body moves. But as we had already seen, if the body moves and comes back to where it started from, that is, it follows a closed path, then displacement can be 0 even if the body moves. Distance and magnitude of displacement. Well, by definition, magnitude of displacement is the length of the shortest path between the 2 points, and hence it is always less than or equal to the distance, and distance is always more than or equal to the magnitude of displacement.